Language model is a backbone of NLP. Hello people, I am Vedanshi, your buddy. Today we are going to discuss language model. The topics that are being covered are language model, types of language model which are statistical language model and neural language model and their subclassifications with applications of language model. Let us start with the introduction of language model. A language model in NLP is a system that helps computer understand and work with the human language. It learns how words are together in sentence and tries to predict the next word in a sentence based on that word that comes before. Think of it like this. When you start a sentence like I am going to the dash, the computer can guess the next word, probably which will be store or park or school, based on how people usually talk. Key ideas. Understanding sequence of word. A language model looks at the sequence of word and learns how likely if the one word to follow the another. For example, I am is likely to be followed by going, but not by apple. Prediction. The word predicts the word that come next in a sentence. For instance, if it's I love, it might predict pizza or coding as possible as next word. Text generation. It can also help to create new sentences or text. For example, if you give it a start like once upon a time, it might generate a full story based on the pattern it learned. Imagine you read a lot of books and notice the people often say, I am going to the and then store or school. Based on that, if you were a language model, you would learn to predict that after I am going to the next word probably will be something like store or school. Shifting our gears to the topic types of language model. There are major two types of language model, statistical language model and neural network model. In statistical language model, we are going to learn about two models, N-gram language model and Markov language model. In neural network language model, we are going to learn about four language models. Feed-forward language model, recurrent neural network, long short-term memory and gated recurrent units, transformers. Statistical language model. A statistical language model is a tool that helps computer to understand and predict how words are likely to appear together in a sentence. It works by looking at the pattern in different amount of text and using these patterns to guess what comes next to the sequence of words. Imagine you are typing a sentence like I want to eat at the dash. A statistical language model would predict the next word might be a restaurant or mall, based on how people use these words together often. In short, a statistical language model is a system that uses pattern in language to predict which word is most likely to come next in a sentence. It does this by studying lot of text and learning how words are related to each other. Advantages of statistical language model. Simplicity. Statistical models are easy to set up and understand. Efficiency. They are faster to train and use, making them good for quick tasks. Interpretability. You can easily see how the model works and understand why it makes certain predictions, which can be helpful in areas like speech recognition or troubleshooting. In types of statistical language model, the first is n-gram model, the most common statistical model. An n-gram model is a type of statistical model that looks at the sequence of words in a sentence. The n in n-gram refers to the number of words the model looks at to predict the next word. If n is 1, the model looks at the one word at a time. If n is 2, the model looks at 2 words at a time. If n is 3, the model looks at 3 words at a time, and so on. The basic idea is that the more words the model considers, the better it predicts the next word because it has more context. In simple words, unigram looks at each word separately, ignoring context. Bigram look at the pair of words considering the previous word. Trigram looks at the triples of words considering the two previous words. Let's now talk about Markov model. A Markov model is a way for computer to predict the next word in a sentence based on current word. The key idea is that the future depends only on present, not the past. Simple example. In a bigram model, if we have the phrase I love, the model will predict what comes next based on the word love, not on the earlier words like I. The probability of next word to the given word is the formula of Markov model. Coming to the neural language model. Neural language model are a type of computer model used to understand and generate language like how humans speak or write. Unlike older models, which only look at the short sequence of words, NLMs are used technology called neural network to look at the longer stretches of text and learn more complex patterns in language. Overall, NLMs are more powerful than the older models because they can handle complicated language patterns, understand longer pieces of text, and make smarter predictions. Advantages of neural language model. Contextual understanding. They can understand the full meaning of sentence, not just a few nearby words. Continuous representation. They turn words into numbers that show how similar or different words are in meaning. Flexibility. They can be used in many different tasks without needing separate models. Scalability. They get better as they learn from more and more data. Types of neural model. Feed-forward neural network. Feed-forward neural network are basic models that predict the next word based on previous words in a sentence. They use special number representation for words called word embeddings. These models were better than old models like n-grams, but they could only look at a smaller part of sentence, so they messed up the bigger picture sometimes. Recurrent neural network. RNNs are designed to process sequence of words one at a time, and they remember what they have seen through the hidden state. This allows them to understand the relationship between words over time and handle sentences that change as new word added. But vanilla RNNs struggle with the long sentence because they forget earlier words due to the vanishing gradient problem, which makes it hard to keep track of important information over longer sequence. Long short-term memory and gated recurrent unit. LSTMs and GRU are advanced versions of RNNs designed to solve the problem of remembering long-term information, which vanilla RNN struggle with. LSTM have special memory cell that helps the store important information for a long time. This memory cell can keep the track of useful details over long sequence of words, helping the model remember context from earlier parts of the sentence or text. It has three gates. Forget gates decide what information to forget. Input gate decides what new information to store. Output gates decide what information to use for prediction. GRU are like simpler version of LSTM. They still use gates. Update gate combines the function of the forget and input gates in LSTMs. Reset gate helps decide how much the past information to forget. Now transformers. Transformers are more powerful than older models like RNNs because they don't process words one by one. They look whole sentence at once. They use self-attention to figure out how words are connected, no matter how far apart they are. They are faster to train and can handle long-range relationships in language better. Transformers are a big leap forward in how computers understand languages. They work very differently from older models like LSTMs and RNNs. BERT, GPT, and T5 are examples of transformer models that can do different tasks like answering questions, writing text, and translating languages. Now the last topic of today's video, application of language model. Text generation. Creating new meaningful text based on a prompt. Speech recognition. Turning spoken words into written text and fixing errors. Machine translation. Translating text between languages naturally. Question answering. Finding the best answer to the question from a text. Text summarization. Shortening long text while keeping key ideas. Sentiment analysis. Determining if a text is positive, negative, or neutral. Hope you find this video useful. If you find the video useful, be connected to our channel. Thank you.